Okay, so this one quite straightforward lah. Newton's. You answer this correct. Which direction? Opposite or to the left also can. The frictional force is to the left also can. If roughness increase, then more friction, then the reading will be greater lah. So I think this one quite standard, so it's okay. This one you should have done it. But as you're doing this, you need to convert to meter square. Do you know why? Pascal is newtons per meter square. So when you're doing your calculations, if you do something like this, meter square and cm square cannot multiply. That'd be wrong. Do you know how to convert to meter square? 4 times 10 to the power what? How do you convert 4 cm square to meter square? Or what should I divide by? What should I divide by? To convert 4 cm square to meter square, you can start with changing this to 4 cm times 1 cm. 4 times 1. If you have any other numbers, 15 cm square, for example, just take 15 cm times 1. Why? Because cm times cm will be cm square. It's like x times x give you x square. So cm times cm will be cm square. Then you convert each of them individually. How to convert cm to meter? Times 100. So 1 cm is 100 meter. Is that correct? 100 meters is very wide. Now this is 1 cm. So what do you do? If you don't multiply, you have to divide. It's either multiply or divide. There's nothing else. So it's divide by 100. So what is 4 cm in meters? How do I convert 4 cm to meters? 4 over 100. How do I convert 1 cm to meters? So what do I get in the end? It's also 4 divided by 10000. 100 times 100 is 10,000. 4 divided by 100. So over here should be 1000. 4 divided by 100. So be sure to convert that before you do anything else. I had many students losing marks because of that. So this one you got correct. I would say your answer is almost correct, but you do need to mention something like since. So area of A in contact with the wall is lesser. This is what you wrote lah. Um, this one mark. Since the same force is applied. So that's that crucial another mark to get. Then you can measure about pressure A will be more than pressure B. And pressure equals the force over area. So again, something that many students leave out in the answering part. Because if you don't mention that the force is the same, then you cannot use the equation to go and compare. This equation, right, when this one lesser, this one increase, right, is assuming that this is constant. If the force changes, then you cannot use it to compare. One of the variables must remain constant, then you can compare the other one. This one you did correct. You calculated. I think is fine. Okay, just make sure that the area in contact is meters, which it is. You don't need to convert anything. So no issue with this lah. Right? So the next part is energy, which I want to go through with you. And it starts from here. Um, so in general, right, when certain things happen, there's something what we call work done. So example, if you push an object, let's say you got a younger sister, right? Yeah. Let's say you push your sister is standing on the block, then you push her. Okay, if you push her and everything is moving in the same direction as to what you push, there's something called the work done. All right. Now, the the key is must be in the same direction. And there's a formula here which is force times distance. And the SI unit is joules. So what does it mean? Let's say your sister lah, I'm assuming she's about 40 kg, for example. Okay. And let's say there's no frictional force, you apply 100 Newton force. So F here is equals to 0. And let's say the distance moved is 10 meters. Okay. The work done in this case by you would be 100 times 10. Work done equals to force times distance. So force, you exert 100 Newton force, and the distance moved is 10. So it'd be 1000, what? What unit would it be? Joules. 1000 J. So unit must put down. Now, since this is SI unit, it's based on meters also. So 10 meters is fine. If I put 10 cm, I must convert to meters. Okay? Sometimes I like to put the units inside so that I can remind myself if I need to convert. This is a topic that has a lot of math involved. So be sure to have your calculator and everything else handy when doing the question. Now, so this is 1000 joules and is a form of energy. Can you tell me where the energy came from? Hmm? It came from you pushing it. Which part of you? Your muscles. Foot in the muscles. Do you recall primary school? They talk about that, like Jane was cycling, then describe, or they ask you to write down the energy transfer or the energy conversion. Then you always start with foot in muscles of Jane. So this energy will come from muscles, or from the foot in the muscles. Okay? The foot in muscles allow you to do this work, causing your sister to move. All right? Now, as your sister move, so moving is a form of, there's energy lah. There's energy when you move. What kind of energy is that? That involves moving, kinetic. So we can say, Callista does work on her sister when she pushes her. The 1000 joules of work done was converted from the foot in the muscles. The foot is then used, the work done is then converted to kinetic energy of her sister. So that's how you transfer energy to your sister. So your sister is moving now. Whee! Very fast. So I hope with this example you can understand what it means by work done. Work done means something is moving through a certain distance and there's a force applied. Okay? Important thing also is to understand when there is no work done. So this sentence is important. No work is done. Okay? This part is important because there's a lot of questions that can be asked from there. Lah. Okay, so let's review this sentence. An object remains stationary when a force is applied on it, or an object is carried by a person even the person moves forward. The first one is quite easy to understand. Stationary. What is the distance moved when you're stationary? 0. Distance moved equals to 0. So therefore, the work done is force times 0 equals 0. Lah. So no work done. Example, I'm pushing against the wall. So if I push against the wall, is the wall going to move? No. So therefore, there's no work done. Okay? The second part is difficult to understand. Are you right now first? So the second part is difficult because um, you are moving, but you're just not moving in the same direction. So I give you an example. I'm holding this pen out like this. I'm holding this pen. Okay. Now, where's the weight? Below lah. So when I hold like that, I'm just holding it in place and I'm exerting an upward force so that I can hold the pen here lah, in my hand. Now, if I move forward like this, if I move forward, where's the distance? Here. Okay, but my force is up. In the distance in the same direction as my force as I move forward. The distance is here, my force is up. Because I need to push upward to hold the pen here, man. So where is the distance? If the distance is here, the force is up. Is that work done? There is no work done. Because work done must be moved in the same distance, in the same direction as the force. If my force is up and I'm moving towards the right or your left, then there is no work done. So that's crucial. Okay? Meaning to say, if you look something like that, the object, the force is up, but the distance moved is here. There is no work done. Okay? Distance is not in the same direction as the force. Okay, the rest here is example of how to calculate work done, but we covered that already, so you can read on. Hmm, what in the world is that? Okay, so this one also interesting, huh? Um, maybe I should. I think there are some examples later. I don't want to give you everything one shot and confused. We're gonna leave that later. Yeah, one by one. A work done can be a tricky thing. Okay, so let's talk about this. Now, if you're pushing a force that is upwards, okay, naturally you will want to find the distance move in the same direction as the force. If the distance is the same direction, then the answer will be 8 times 12, which is 96. Okay? But sometimes they can make it funny by giving you this. Then they ask you, what is the distance move? Find, they ask you the work done. So is it 12 times 8 or is it 12 times 5? Why not 12 times 5? Yeah, the distance is in the same different direction as the force. The force is moving this way, whereas the distance is this way. Okay? Okay, moving on. Next, conservation of energy, as I like to call it COE, lah. Nothing to do with cars. Now, it's a short form that I may use it from time to time, lah. Have you heard of this before in primary school? Hmm. They should teach that in primary school. So a law of conservation of energy states that energy cannot be created nor destroyed. Does it sound familiar? When it's used, it changes from one form to another through energy transformation. So you may hear something like GPE to KE, that kind of thing comes from here, lah. Okay, so I give you an example, lah. You have a ball rolling. You start off with 100 joules of GPE. GPE is a form of energy. Anything that has energy, right, must be in joules. Last time, maybe you in primary school it'd be 100 units because you didn't know the meaning of the unit of energy. But now that you know it's joules, so it starts with 100 joules. And the ball is not moving at all. So no kinetic energy, zero lah. What's the total? 100. Total refers to all the energy in the system. The system in this case refers to the ball lah. How much the ball has. Now you roll down all the way to the bottom. Do you have any more GPE? No. Then what should your KE be? 100. So all GPE converted to KE. So you check, this one was 100 at first, 0. Now 0 and this 100, but total remains as 100. All correct. Okay, I'll tell you what is not correct. Example, I put 10 here. Cannot be 10 because then the total must be 100, ma. 10 plus 100 is what? 110. So not correct. Energy is not conserved. Means something is wrong. That's the meaning of conservation energy. I give you another example. I put 10 here, and then I get this. Is it correct? No. This one should be 110. Okay, and this should be 110, 110. Total should be 110, 110. K should be 110, for example. If I put a 10 here. Because all the numbers must add up to be the same total. Then if you look at the last one, it didn't go up to the same height. This one is higher than lower. So you got maybe 50 joules, for example. If it got 50 joules, KE must be 50 lah, because it had 100 at first, ma. 150 goes to here, it must remain as 50. So that the total will always be 100. Total energy will remain the same at all times. Okay? Now, you can even convert this into a graph. This part of science got graph one. So you can convert this into a graph. Let's call this A, B, and C. And this is your energy. So the first graph, I use solid line. This is your, this will be your, no, hang on. This graph will be your GPE. Okay? The second graph will be your KE. I use dotted. So this is 50 joules and this is 100. So A, B, C, you will look like that. 100 drop to 0. You see here? 100 drop to 0. Then go up to 50. 0 go up to 100, then drop to 50. Can you tell me how your TE graph would look like? TE, total energy. How will it look like on this graph? 100, 100, 100. It'd be a flat line. Yes. That's your TE graph. So they may also ask you this kind of question. Okay, energy always conserved means that the total amount, total before equals the total after, meaning to say 100, 100, 100. That's the meaning of conservation energy. All right. The next part is more of reading lah, bedtime reading. So I'm sure you may have seen some of this in your primary school. So let's go through. Um, there are different types of energy sources in this world. There's solar energy, there's biomass, there's fossil fuel. Okay. There are also others like water, wind, radioactivity. All right. In Singapore, what do you think we mostly use? Water? No, we can't. It's one of this. No, the main one must be the main. Fossil fuel, particularly coal. This is what we do in Singapore. So in Singapore, we have like Sinoco, Keppel. All right, these are the ones that supply power to your house, to this place. And what they do is that they burn coal. Now we are moving a little bit more towards this. Okay, you see a lot of like solar cells on the rooftops, right, of the HDB flats. But it's a small amount, tiny amount. It will not be the main uh, until something else comes along. Solar is a better alternative, but it won't give you that much energy compared to coal. Okay? The biomass, more of it later. Water, we can't. Water, you need a dam. You need like mountains, okay, big mountain, water flows down. Then you can get it. So um, we don't have that kind of features in Singapore. Wind, you need lots of land, which we rather use to go and build something else. Waves. Now, some countries they use wave to generate power, but not in Singapore. You need a large coastal area, which we don't have. Australia got a lot lah. Norway also. But what I read is the amount of investment is not paying off lah. The energy you get is still very little compared to fossil fuels and all that. This one is a very good uranium, good source of energy. A lot of countries on the other side of the Cold War, uh, the ones that they are currently having a war right now also, Ukraine and Russia, they use their radioactive power plants. They have nuclear lah. All right. US also got, but not a lot lah. Is the initial investment is a lot to build the whole power plant. But once you get things rolling, right, energy is so much, and you don't need to keep putting in more uranium. Uranium can last for a long time. So the cost drops a lot after you set up. So when you build the plant, very expensive. But after it's up and running, and people start paying you money for the power that you generate, the cost will drop a lot. And it can run for years, which is why Ukraine and Russia love this kind of technology. However, it's dangerous because if there's a damage to the building and radiation leak out, people get affected. It can cause cancer. Have you read about World War II? Oh, not yet. Hiroshima, Nagasaki bombing, the nuclear bombs, no, atomic bombs. Maybe next year lah. So radioactivity is not good for human beings. Radiation. Having said that, not all radiation is bad. Some radiation are okay. Like right now, the light here at the top is a form of radiation and it's harmless to you. Um, Radio waves are also another form of radiation. Like when you're in the car, you listen to the radio, that's a form of radiation. And it's harmless to you. But this kind of uranium, the radiation it give off, is very harmful to you. Okay, so let's talk about biomass or biofuel. Biofuel basically are things that comes from living things, living plants. Okay, example, animal waste, wood, all that. You can burn it, you can get energy from it. They are renewable because you can grow new plants to replace the old ones. Renewable means can be replaced in a short period of time. Okay, so these are some example of biomass. This is you're gonna learn this again in Sec 4 chemistry. Ethanol. It's a form of alcohol. Basically, you can convert sugar to alcohol. Once you get alcohol, right, you can put in your vehicle and use it as fuel. Some people say it's very good because there is no net carbon output. So does not contribute to greenhouse gas. Now, why is it no net carbon output? So here's the thing. The sugar here comes from where? Comes from plants. How do plants make sugar? Photosynthesis. Now, photosynthesis involves absorbing carbon, which is a good thing, right? You absorb carbon, there's less carbon dioxide in the air. Absorbing carbon dioxide. Now, inside the car, when you're combustion, when you're burning combustion, You produce carbon dioxide. Now, whatever you produce, right, is based on the carbon dioxide they absorb, mah? So because of that, right, there's no net carbon output. Whatever produced equal to, or whatever carbon produced equal to whatever carbon absorbed. Yeah. So ugly. Whatever amount of CO2 produced is absorbed by plants for photosynthesis. So it's carbon neutral, lah. So they say that this technology is very good lah for transportation. Okay. Um, moving forward. How much do I have? Oh, not too bad. Okay, next is solar energy lah. Solar energy, I think you covered it in primary school. So this is about solar panels. That's what they do, convert solar energy to heat and electrical. It's a renewable energy source. So all you need to do is just read this. Um, there are three main types of fossil fuels: coal, natural gas, and oil. I mentioned coal just now. Natural gas and oil, they are also available, but Singapore uses mostly coal. And coal is not the same as charcoal. Charcoal is burnt wood. Coal is a remain of a wood that died 65 million years ago. That through the pressure action of the soil causes the wood to become compressed and smaller until it becomes something very black and solid. That's coal. Charcoal is I take a piece of wood outside, I burn it, it become black, and then I use it for barbecue. Different types. Okay? So you can read this. Fossil fuels are non-renewable. Why? Because they come from dead dinosaurs and trees, which are formed 65 million years ago. So that takes a long time. Nuclear, you can read this. Um, I talked about it just now, lah. How Russia and Ukraine, they have nuclear power plants. It's caused by splitting the atoms. So I give you an example. You know atoms, right? Like lithium, sodium atoms, right? Now, what if you have a very big atom called uranium and we shoot something, hit it, bam, what's going to happen? It's going to split up like an egg. You know, like hard boiled egg. You crack it open. It's going to split up. And then what comes out? Energy. A lot of energy. And that is nuclear. Okay? You can use energy to heat water into steam, turn a turbine, and generate electricity. Geothermal also the same, similar, but except the energy comes from the Earth core. There are certain part of the world where there's a lot of heat that comes out from the ground. So you can use this to actually uh, convert the energy by heating up the water, which turns into steam, and then the same thing lah. Actually, it's all turbine electricity stuff. A lot of our power generation is based on this technology, which by the way is it was discovered by Tesla. Not the car company Tesla, but there was a guy called Tesla, Nikola Tesla. Tesla and Edison were enemies, and Edison really hated Tesla. But if not for Tesla, we wouldn't have this technology today. It's a very good technology to convert other kinds of sources of energy into power, what we need, which is electrical energy. Have you heard of wireless charging, where you put the phone on the pad and then it charges? That is a Tesla technology as well, which is one thing Edison didn't like. Edison hated it. He wanted to suppress it. He kept suing Tesla to prevent his technology from being used. Tesla died a poor man as a result. Okay, we're done. The rest you can read, and we are ready to try all the remaining questions. But let's have a break first. Then we'll work on it. Okay, 10 minutes. I'll see you back here. Okay, question 10. What's the answer? C is correct. 11. You have to wait 65 million years to generate. So it cannot be renewable. Hydroelectric. Okay, hydroelectric is from the water falling from a great height, going down. So you have water falling from a great height. Then the plant is below. So it generates the power from there. Yeah, why would you think it's A though? Chemical potential to heat and sound? You're generating electric power. So there's only one answer that has electrical energy. So it's B. Okay? 13? Yep. 14? Not an appropriate way. Minimize the use of vehicles by using public transport instead. There's a better answer to this. Not an appropriate way. Yeah, because if you receive natural sunlight, why do you need energy efficient light bulb? Yeah, they are energy efficient, but there's natural sunlight, so you don't need that. 15? Yeah, this is correct. 16? Mm-hmm. 17? Yep. 18? You're asking for not true. That's true, no work done, remain stationary. If it's perpendicular, then there's no work done. So it cannot be perpendicular. It's parallel actually. That's what makes it not true. Should be parallel. Yep. Original position doesn't move. 20? 500 times 0.25. Yeah, see. Okay, we are done. So what's for homework? Well, you know what's coming. Finish the remaining MCQs. Work on question 5, 6, 7, and 2. Basically, all the remainder open-ended lah. It's not a lot lah, because we've been actually working on it piece by piece. So you should be fine. And once you have your paper back, please let me know how it goes. Should take a look at it. Okay, that's all. Do you mean your stamp sticker card thing? Okay. Well, bring it next week. All right, and we are done.